All right, we're going to take a look at what we call disk and washer methods. These are methods to find the volume of a region that is rotated around some line. So let's start with an example here. We have y equals root x. And let's say that we're trying to build a nose cone for a rocket that has the shape of this curve revolved around the x-axis. So if we rotated that around, it would create this sort of conical shape, although it's rounded there near the top. We want to find the volume of this cone. So the way we can think of this is slicing this into disks or cylinders and adding their volumes. So if we sliced it down, the radius of that disk is the distance from the x-axis up to the curve y equals root x. And the volume of that disk would be pi r squared times the thickness. In this case, that thickness is dx. The radius is y equals root x, so the radius is root x. Thickness is dx. So we end up with an expression for the volume of one of those disks, pi times root x squared dx. So if we want to find the volume now, we add up all these disks from x equals 0 to x equals 4, so we take the integral. And we can simplify and evaluate. So this is what we refer to as disk method. The shape of the slice is a disk, and we use this formula right here. Volume equals, well, it comes from the volume of a cylinder, pi r squared times the height. So we have pi r squared dx or pi r squared dy. So we just look at our sketch to determine which direction we're slicing, whether our thickness is dx or dy, and then everything comes from there. So let's look at the region that's between the curve y equals x squared, y equals 2, x equals 1, and the y-axis. And we're going to rotate this curve, or this region, around the line y equals 2. So you can see that region there, bounded between all 4 of those curves. And we're going to go around the line y equals 2. If we do that, we end up with this disk. So this disk has a thickness in the x direction, so that's dx. The radius is the distance from y equals 2 to y equals x squared. So we do top minus bottom. The radius is 2 minus x squared. And we can use our formula. Integrate from x equals 0 to x equals 1 of pi r squared dx, which would give us 9.006. If we have the region between x equals 1 over root y goes from 1 to 4, and we're also bound by the y-axis, and we're going to revolve around the y-axis. We want to find that volume. So we rotate around. Well, one of these disks would have thickness in the y directions, that's dy. The radius is the distance from the y-axis to the curve x equals 1 over root y, so r equals 1 over root y. So we have integral from y equals 1 to y equals 4 of pi r squared dy, which would give us 4.355. If we look at this example here, we have this cooling tower. We know that the height of the tower is 500 feet, and the shape of the profile there can be given by this function, or this equation shown below. So if we want to find that volume, we would be revolving this around the y-axis from y equals 0 to y equals 500, and we could calculate the approximate volume of that cooling tower. All right, now let's say we have this region bounded between y equals 2x and y equals x squared, which goes around the y-axis. We want to find that volume. Well, as that thing rotates around, you'll see that the inside of this shape ends up being hollow. So if we take a horizontal slice from one curve to the next, we get this shape here that is open on the inside. We refer to this as a washer, just like the washer you would use if you were putting in a bolt. So the volume of the washer would be the volume of the outer portion minus the volume of the inner portion, pi big R squared minus pi little r squared, times the thickness. In this case, the thickness is dy. And we can factor out pi from both of those and just bring that to the outside. So if we started with y equals x squared, that gives us root y equals x. We would start with y equals 2x, that gives us y over 2 equals x. So the volume is the integral from y equals 0 to y equals 4 of pi times big R squared, which would be the outer radius, that's x equals root y, minus little r squared, that'd be the inner radius, that would be x equals y over 2 dy, and we get 8 pi over 3. So we refer to this as the washer method, and it's really just the disk method twice. We're taking disk method of the outer portion and subtracting the disk of the inner portion. But we can put it all together in one formula by saying pi times the integral from a to b of big radius squared minus little radius squared dx, or dy. Let's say we take this same region and we go around the line x equals 3. So we can see what that shape would look like. So the outer radius now is the distance from x equals 3 to y equals 2x, or x equals y over 2. And the inner radius is the distance from 3 to root x. So we have pi times the integral from 0 to 4 of big R squared minus little r squared. So we just bring those down. And we end up with a volume of 16 pi over 3.